Imagine a realm beyond Neptune, filled with icy bodies and shrouded in mystery. Welcome to the Kuiper Belt, a region of our solar system that continues to puzzle scientists. This vast frontier of space is an icy belt of debris, located at the very edge of our solar system, where the sun's influence wanes and the interstellar void begins. The Kuiper Belt is named after Gerard Kuiper, an astronomer who predicted its existence in the 1950s. But it wasn't until the early 90s that its first member, an icy body named 1992 QB1, was discovered. Since then, more than 1,000 objects have been identified within this region, but it's believed that over 100,000 more are waiting to be discovered. Stretching from about 30 to 50 astronomical units from the Sun, the Kuiper Belt is home to a variety of icy bodies, from tiny fragments to dwarf planets like Pluto and Eris. These icy remnants are considered the building blocks of our solar system, leftovers from its formation over 4.5 billion years ago. They provide a frozen snapshot of the early solar system, offering clues about its birth and evolution. But what makes the Kuiper Belt so fascinating is not just its location or its inhabitants, but the many mysteries that it holds. For instance, why do some objects in the Kuiper Belt have highly eccentric orbits, swinging out far into space before returning close to the Sun? What role did the Kuiper Belt play in the formation of our solar system? And could there be a ninth planet lurking in its depths, as some scientists speculate? These questions and many others make the Kuiper Belt a subject of ongoing study and a source of endless fascination. As our technology advances and our spacecraft venture further into the fringes of our solar system, we can hope to uncover more of its secrets and better understand our place in the cosmos. Now let's delve into the top 10 unsolved mysteries that make the Kuiper Belt so intriguing. Starting at number 10, we have the mystery of the binary systems. So, what exactly are binary systems? Picture two celestial bodies such as asteroids or dwarf planets orbiting around a common center of gravity. Now you might be wondering, what's so strange about that? Well, let's take a closer look at the Kuiper Belt. In the vast expanse of the Kuiper Belt, binary systems are surprisingly common, yet they're a bit of an anomaly. The typical distances between objects in this region are so vast that the likelihood of two bodies getting close enough to form a binary system is quite slim. So how do these binary systems come into existence in the first place? There are several theories. Some suggest they formed during the early days of the solar system, while others propose they're a result of gravitational interactions. But as of now, these are just theories. Until we have more data, the binary puzzles of the Kuiper Belt remain unsolved. Moving on to number 9, we find ourselves puzzled by the eccentric orbits of some Kuiper Belt objects. Now, when we say eccentric, we're not talking about a zany personality trait. In astronomy, eccentricity refers to the deviation of an orbit from a perfect circle. The greater the eccentricity, the more elongated the orbit. Some objects in the Kuiper Belt, like the dwarf planet Eris, have highly eccentric orbits, and it's a big cosmic conundrum. Why, you ask? Well, according to the laws of celestial mechanics, objects in the Kuiper Belt should have almost circular orbits. But as it turns out, reality is a bit more complicated. Some theories suggest that gravitational interactions with Neptune may be responsible, while others point to an undiscovered massive planet in the outer solar system. The truth is, we're still not sure. These eccentric orbits continue to baffle scientists, making them our number 9 mystery. At number 8, we have the mystery of the missing intermediate-sized bodies. The Kuiper Belt, a frigid expanse beyond Neptune, is a treasure trove of small icy bodies. We see a vast range of sizes, from tiny specks of ice to dwarf planets like Pluto. But here's where the plot thickens. There's a surprising lack of bodies in the intermediate size range. We've got the big guys, we've got the little guys, but where are the middle guys? Some astronomers suggest that the gravity of nearby giant planets might have ejected these intermediate bodies out of the Kuiper Belt. Others theorize that they may have collided and shattered into smaller fragments. But the truth is, we just don't know. This size distribution puzzle is akin to finding a city full of skyscrapers and bungalows, but no townhouses. The absence of these bodies is one of the many enigmas of the Kuiper Belt. At number 7, we question the role of the Kuiper Belt in the formation of our solar system. The Kuiper Belt, a vast icy realm beyond Neptune's orbit, is a treasure trove of clues about the early days of our solar system. It's a bit like the attic of our cosmic home, filled with ancient relics that can tell us stories about our past. Let's delve into some of the theories about how this icy belt may have played a role in forming our cosmic neighborhood. Firstly, there's the NICE model. And no, we're not talking about being polite here. Named after the city in France where it was first developed, this model suggests that the giant planets of our solar system originally formed closer to the Sun. Over millions of years, gravitational interactions caused them to migrate outward, scattering icy bodies into what we now know as the Kuiper Belt. The NICE model paints a picture of a dynamic early solar system, where planets are not stationary, but move and evolve, and the Kuiper Belt in this scenario is a byproduct of these planetary dances. It's a compelling theory, but it's not the only one. Some scientists propose that the Kuiper Belt formed where it is today, from a primordial disk of gas and dust. These icy bodies, they suggest, are remnants of the building blocks that failed to coalesce into a planet. Instead, they remained as a vast icy belt, a frozen snapshot of our solar system's infancy. Then there's the idea that the Kuiper Belt could be the source of short-period comets, those that orbit the Sun in less than 200 years. These comets could be Kuiper Belt objects that were nudged inward by the gravitational forces of the outer planets. Despite these theories, the exact role of the Kuiper Belt in our solar system's formation remains a mystery. It's a tantalizing puzzle that continues to challenge and inspire astronomers. As we continue to explore these distant icy realms, who knows what secrets we might uncover about our cosmic past. Halfway through our countdown, at number 6, we have the puzzling icy surfaces of Kuiper Belt objects. The existence of such icy terrains in the far reaches of our solar system is a conundrum that continues to baffle scientists. It's surprising because the Kuiper Belt is a region of space beyond Neptune that is billions of kilometers away from the Sun. How can it be that these objects, so far removed from the heat and light of our star, have surfaces blanketed in ice? There are theories, of course. Some scientists propose that these icy surfaces are remnants from the early solar system preserved in the cold outer reaches. Yet others suggest that these icy mantles could be the result of complex chemical reactions triggered by cosmic rays. Despite these theories, the exact origins and nature of the icy surfaces remain shrouded in mystery. The icy terrains of the Kuiper Belt add to the long list of unsolved mysteries. At number 5, we wonder about the varying compositions of Kuiper Belt objects. This far-flung region of our solar system, beyond the orbit of Neptune, is home to a diverse array of celestial bodies. Each one is a unique world with its own distinct composition. Some are icy comets, while others are rocky asteroids, yet they all exist within the same region of space. What's more, we've discovered that some of these bodies contain organic compounds, the building blocks of life. So, why does such a variance exist? Why are there icy comets and rocky asteroids sharing the same space? And how did these organic compounds come to be on these distant bodies? These are questions that continue to perplex scientists. The Kuiper Belt is like a cosmic jigsaw puzzle with missing pieces. We have some of the pieces, but not all of them. The composition variance in the Kuiper Belt remains an unsolved puzzle. Moving to number 4, we explore the unexpected temperatures in the Kuiper Belt. Nestled well beyond Neptune's orbit, the Kuiper Belt presents a conundrum that has left scientists scratching their heads. One would presume that an area so far removed from the Sun would be frigid, but the reality is quite the contrary. The Kuiper Belt is surprisingly warmer than anticipated. This unexpected warmth is not a result of the Sun's heat, as the intensity of the Sun's rays diminishes with distance. So, what is causing this unexpected heat? Several theories have been proposed, with some scientists suggesting that the heat could be a result of radioactive decay within the Kuiper Belt objects. Others propose that the unexpected warmth might be due to the gravitational interactions between the belt's objects. However, none of these theories have been conclusively proven, leaving the source of the Kuiper Belt's heat an unsolved mystery. The unexpected temperatures add to the enigma of the Kuiper Belt. At number 3, we have the mystery of the dark red coloring of some Kuiper Belt objects. Now, when you imagine space, the first color that likely comes to mind is the black abyss of the cosmos, sprinkled with twinkling stars. So, the discovery of dark red objects in the Kuiper Belt was, to say the least, a surprising find. Why, you may ask, is this coloration so unexpected? Well, the Kuiper Belt is a region known for its icy bodies. Ice, as we commonly know it on Earth, is transparent or white. So how can ice in the Kuiper Belt be dark red? This has led to several theories. Some scientists propose that the red could come from complex organic molecules, or tholins, caused by cosmic rays hitting the icy surfaces. Others suggest that it could be due to irradiation of ices by solar radiation. But the exact cause? Well, that's still up for debate. The dark red coloring of these objects remains one of the top unsolved mysteries of the Kuiper Belt. Almost at the top of our list, at number 2, we have the potential existence of Planet 9. This enigmatic and yet-to-be-discovered entity, thought to be lurking in the fringes of our solar system, might just be the key to unlocking many of the mysteries of the Kuiper Belt. The theory of Planet 9 was first proposed by astronomers in 2016, and it's been a hot topic of debate ever since. According to this theory, there's an unseen planet, possibly about 10 times the mass of Earth, orbiting far beyond Neptune. Now, you might be wondering, if we haven't seen it, how do we know it's there? Well, it's all about the gravitational pull. Scientists have noticed that several objects in the Kuiper Belt have peculiar orbits, ones that don't quite follow the rules. These odd orbits suggest that there's a substantial mass out there, tugging at these objects and pulling them into their unusual paths. This unseen influencer is what we refer to as Planet 9. If it exists, it could explain why some Kuiper Belt objects have such eccentric orbits, a mystery that has puzzled scientists for years. But that's not all. The existence of Planet 9 could also explain the presence of certain high-inclination objects in the Kuiper Belt. These are objects that orbit at an angle to the plane of the solar system, and the gravitational influence of a massive planet could be just the thing to place them in such tilted orbits. Of course, until we actually lay our telescopic eyes on Planet 9, it remains a theory, but it's a compelling one, and the search for this elusive planet continues. If it is found, it would not only confirm the theory, but also provide us with a whole new understanding of our solar system and the mysterious realm of the Kuiper Belt. The potential existence of Planet 9 is one of the most exciting mysteries of the Kuiper Belt. And finally, at number 1, we have the ultimate mystery, the origin of the Kuiper Belt itself. This icy region beyond Neptune's orbit, teeming with frozen remnants from the birth of our solar system, has long puzzled scientists. Theories abound, but firm answers are elusive. Some suggest that the Kuiper Belt was formed from the primordial solar nebula, the cloud of gas and dust from which the sun and planets emerged. These icy bodies, they propose, are leftover building blocks that never coalesced into a planet. Others argue for a more dynamic origin. They speculate that the gravitational influences of giant planets like Jupiter and Neptune, early in the solar system's history, could have scattered these icy objects into their current distant orbits. Yet despite these theories, we're still far from a definitive answer. The Kuiper Belt, with its icy bodies hurtling through the outermost frontier of our solar system, continues to challenge our understanding. The origin of the Kuiper Belt remains the greatest unsolved mystery. The Kuiper Belt, a region beyond Neptune, is a treasure trove of mysteries waiting to be discovered. It's a place where icy bodies dance in eccentric orbits, where binary puzzles confound our understanding, and where the very origins of our solar system may lie hidden in the frosty darkness. The icy surfaces, with their strange dark red coloring, hint at a composition variance that remains an enigma. The unexpected temperature fluctuations and the absence of intermediate-sized bodies add more layers to the puzzle. The potential existence of a yet-to-be-discovered planet dubbed Planet 9 further stirs the pot of cosmic mysteries. We've taken you on a journey exploring these fascinating conundrums, from the role of the Kuiper Belt in the formation of our solar system to the intriguing binary puzzles it presents. As we continue to explore the far reaches of our solar system, who knows what other mysteries the Kuiper Belt will reveal? Until then, the Kuiper Belt remains a realm of unsolved mysteries in our celestial backyard. Thank you for joining us on this fascinating voyage through the enigmas of the Kuiper Belt. We've just begun to explore this cosmic frontier that never ceases to bewilder and mesmerize us. As we carry on our journey, we can only wonder about the hidden secrets the Kuiper Belt could unveil. But it is essential to remember that this quest to comprehend our universe is a journey we all share. If this expedition has enlightened you with something new, and you wish to be a part of future adventures, please do not forget to like this video, share your thoughts and opinions in the comments section. They are the fuel for our spaceship, are eager to know. What about the Kuiper Belt intrigues you the most? Do you believe in the existence of a Planet 9 just waiting to be discovered? Remember to subscribe and hit that notification bell in order not to miss any of our future voyages into the universe's mysteries. Also, share this video with your friends and family, and let's extend our cosmic curiosity. Each star we discover, each mystery we delve into, brings us one step closer to understanding our position in this vast cosmic ocean. So let's traverse this journey together. Keep your eye on the stars and let your curiosity be your guide until our next exploration.